Welcome to Study Loop.
Hi everyone, thanks for joining me today. What we're going to be looking at is the expression of the acceleration of gravity at a certain height above the surface of the Earth. And we're asked to find that in terms of the gravity at the surface, g0, the height at which we're at and the radius of the Earth. And we're also asked to find the percent error if the wrong gravity term is used. So, as always, we're going to start off with a free body diagram of just any random mass, and that's going to have a weight force acting on it. Now we know that this weight force is simply equal to mg. Now this g we're going to do this arbitrarily right now. So in the instance where mg is at the surface of the Earth, this g will simply be g0, and we know that this is going to be equal to the universal gravitation constant, the mass of the object, the mass of the Earth, divided by the radius of the Earth squared. So by canceling out the masses, we see that the gravity at the surface of the Earth is big G, the mass of the Earth, over radius of the Earth squared. Now, similarly, we are going to have the same mass at a distance h above the Earth. So this weight is now going to be mgh, which is the force of gravity at a distance h above the surface of the Earth, is equal to that same universal gravitational constant, the mass of the object, the mass of the Earth, over, now the distance is going to be the radius of the Earth plus h, which is their height squared. So now you can see there's a little difference between this gravity and the gravity at the surface of the Earth. So we're going to cancel these masses out since they're both on both sides. So here we see that GH is equal to the same universal gravitation constant, mass of the Earth, but there's this different term on the bottom where the radius is different. So just for, we don't have to scroll up, we also know that the gravity surface of the Earth is as shown here. So what we can do is we can actually plug in for these gm values to get the gravity at a height in terms of the gravity at the surface of the Earth. So solving for gm, we see that g0 r squared equals gm. And what we can do is we can actually plug that into our expression for gh and say that gh equals the gravity at the surface of the Earth, r squared, all over r plus h squared. So this is actually our expression for the gravity at a height above the surface of the Earth at a height h. Now our error is actually going to be given, we're going to call that E, and that is simply equal to the gravity at the surface of the Earth minus the gravity at a certain height h, all over the gravity on the surface. And to translate this into percent error, we're just going to simply multiply this quantity by 100. So simplifying this expression further, we can see that this is 1 minus gh over g, and this can be simplified to say 1 minus r squared all over r plus h squared. Now this, this quantity right here multiplied by 100 is our percent error. I'll just add that in here as well, just for the sake of continuity. Now, as you can see, the only variable that we need to know is h, and in the problem statement we're asked to solve for an h of 0.625 miles, and plugging that in to this expression shown here, we find that the percent error is very small. It's 0.0315%. We're also asked to solve for a height of 625 miles. And when plugging that into the same equation, we see that the percent error is very significant at 25.4%. So let's box off our answers. and that's it.